Good morning, good morning. Dan was telling me, he says, they can't move around. I'm stuck in this corner. I'm used to jumping around when you're moving. Yeah, you see, right there, he's blocking me up. In my presentation, I'll be jumping on tables and all this stuff, to keep you awake anyway. These slides, yeah. The title was changed a little, actually, not quite a bit, it was from the email message that Tom sent out. Yeah. The way he phrased it, I'm going to prove the existence of God. He said, oh, wait a minute, I can feel the pressure. You're kidding. People have been much smarter people than I am, have been trying to do it for thousands of years, right? They can't do it yet. I remember one time I was giving the service in a Unitarian church in Cherry Hill. And I asked the minister, Dr. Rudy Nemser, so what about the existence of God? Can you prove that? He's a Unitarian guy. You tend to be brainy people and all this stuff, right? He said, no, the proof of God is not a theological or philosophical question. That's a scientific question. That was about 30 years ago. So I'm still kind of pursuing that. How can we do that tangle? How can we get the science to give us even a glimpse, which is what I'm thinking I'm going to maybe accomplish that today, a little taste, but the proof itself is not. Oh, I did. I think I forgot to put a quarter in there. This, I thought I did. Let me see. This Zoom, share, and there it is, right? How about that? And, all right, that's enough, right? Oh, I see. Okay, but I see I don't know what's on the right side. What's on the right side? Oh, that's important. Yes. Okay. So notice the title is Verify or Disprove the Existence of God and the Human Experience. So, and the title initially was sent out was this one, using astrophysics, bioelectromagnetic, and brain functions to verify, disprove. Oh my God, it's a long, way. No. So I decided to focus in particular on the human experience, okay? In particular, I'm going to focus on awareness. That's probably the closest we can get to that area. And the idea is of being aware, especially being aware of being aware. That's where I'm going to build it up, okay? And that's as far as I can get, really. There will be a hands-on demonstration today, so I hope you're ready for that. There will be pairing. It will come up in a moment. I'll build it up in the baseline. Why do that, and why that demonstration will make sense. But I want you to experience directly, okay, that sense of connection that is non-contact, non-physical, and that we're going to experience. Everybody can feel that. Even animals can feel that. All right. Okay, so let's jump in on that one. Oh, geez, okay, a little background on myself. I can summarize the whole thing. Before chiropractic medicine, I was on the technical side, engineering, working for NASA and the space program and stuff like that. But even before then, my background in Peru was more in psychology. I was studying psychology back then. So when I came to the U.S., I remember asking clearly, I said, hey, how can you get, remember, I'm coming from South America, poor country, underdeveloped, they call it third country now, this is probably a fourth country now, I don't know, there's no such a thing, a fourth country anywhere. Anyway, so I came here and said, what is the fastest way of getting a big paying job? That's the image of the U.S., right? I came here, I had $12 in my pocket. In fact, 12 Susan B. Anthony coins, my collection. Susan B. Anthony, they don't make it anymore. I still have a few of them. But I have 12 in my pocket, and that was it. That was it. I landed in Philadelphia back then. So I said, well, become an engineer. Oh, really? What do you do then? Okay, so I went back to school, got my first background was in mathematics. then the engineering, and then my PhD is in systems engineering. But there was always in the back of my head some nagging feeling about what I really wanted to study was study about the human experience. I wanted to, back to psychology in a sense, or some branch of psychology. And I tried to do that before going to my PhD. I said, maybe I should go back to where I really want to go. But medical school was one of the options. I come from a medical family. My biggest influence was my youngest uncle, who was a medical doctor, but he was a little open-minded, not just a conventional, pigeonhole type of medicine. So he was kind of the one that got me to think about not just the human body from the physiology and that of the neurology and all that, but what else is happening. One experience, and I'm going to share just one little one. My father was ill in the hospital, so we were driving. My uncle was driving, and the two of us were going to the hospital to visit my father. And he's preoccupied on some patients or something like that. He runs a red light. Anyway, police officer pulls him over. And I said, well, I apologize. He said, I'm going to see my brother. Well, kind of a pitch on that, I apologize. I'm sorry for that. Anyway, the police officer let him go. When we got to the hospital, the first question my father asked him, did you get a ticket? I said, what are you talking about? Well, you were pulled over by the police officer. So my uncle looks at me, he smiles and says, you see what's happening? That kind of connections. And other things happen with, I guess you can call it spirits, that's my father, some of my uncles seeing a native indigenous person moving in the house. We had a very old house, and people claimed there was also stuff happening, right? That people couldn't see, sounds and apparitions, right? So that was a number of times it had happened like that. And grew up upper middle class, in countries like Peru, very common to have a maid who happens to be most of them times are indigenous people. So I grew up with a lady, Clotilde, who was a shaman from the mountains. She was surfing the mountain there. And people used to come in, and she would read tarot cards and do the coca leaves, trying to read things. And indigenous from the city would come in to seek her advice. And I grew up in that kind of mindset. I thought that was normal. That was just kind of what you do, right? Until I became civilized, went to school. I said, wait a minute, I'm an oddball. I keep talking about those things. People, you're out of this planet or something, That's kind of got me at that point. I learned to, as a kid, you don't want to stick up, right? So I had learned to shut down, not to talk about things. What got me really getting the biggest mode of understanding what reality is, how we perceive things, which you will see a lot of the lecture will be talking about how we perceive the reality and what are the filters that reality and creates our mindset on how we think things are, right? Including awareness. Again, I didn't know I don't know if you know what's an amblyop. I'm an amblyop. I have no stereo vision, and congenitally. So I can see with one, I can at will shift eyes. And the color and saturation are different from right eye to left eye. So I learned from the kid, if I'm bored with one eye, I just shift to the other eye, and things are different. Different saturation, different vibrancies, and so that was my form of entertainment. And in school, I remember, I don't know what grade, kids, and my classmate would say, "Oh, such a boring teacher." I said, "Just shift your eyes." I said, "Shift what?" "Shift your eyes." I mean, he said, "What are you talking about?" And then again, I suppressed that, but I kept doing that. I said, "Why? If I look at with the left eye, the redness is different than the redness on the right eye." So I kept thinking, "What is red then?" Keep challenging those questions. But light, that's the reason I work with lasers. Anything with light, I'm involved with light. That's, to me, was kind of the ultimate. Photons, right? Photons. And the electrons and photons go hand in hand. So we will see that the primordial Big Bang at the beginning, what was at the beginning beside the world? That was photons and electrons. And we're talking about that. how we merged from there to where we are today. And how we experience reality the way it is now is based on what happened 13.8 billion years ago. That was come up. So that's kind of the summary. And that's the lecture. So we're finished. Let's go to lunch. What else? No, that's it. Okay. So science, let me a couple of quotations to set the stage. Natural science describes nature as exposed to our method of questioning. So many times the question is more important than the answer. And that has been hammered many, many times. You know, Heisenberg, of course, we all know about Heisenberg, right? I would rather know some of the questions than all the answers. And that's quite true, but that sets the stage on how to think about things, right? And this, I like this a lot, actually. Under what we think, live on that we believe. Quick story in anthropology. Remember, come from the social sciences. There was this priest way back, long time ago, hundreds of years ago, went to Brazil to do some studies about the indigenous people, had never seen, you know, old folks, tribes, you know, primitive people. They don't know science, right? They don't know society. Anyway, so this priest was asking, well, who was an anthropologist, was asking some of the natives about things in nature, which is like a ocean. These people had never seen an ocean. He said, well, it's like a big lake. Well, our lake is this big. No, this is much, much bigger. It can't be. Look at the biggest lake we have is this much. No, this is like a million times. No, come on, give me a break. That just doesn't make sense. It doesn't exist, right? Anyway, he decides to bring a group of people to the coast, to Brazil. And he said, you see this lake? I said, my God, this is the biggest lake ever, you know? And he says, hey, do you see that? There was a ship way out there. And he says, that one is a ship. Describe what a ship is, but you know, you can have 100 people there. No such a thing, right? They used to think canoes, maybe, you know, 5 feet people or something. That's not 100 people. No, that's a big canoe. You can't do that. He said, I don't see it. He said, yeah, but don't you see it? Said, I don't see anything. Finally, he took a boat, got the natives, the indigenous people to the ship. They started touching, they looked at it, then they saw it. Came back to the shore. Yep, I see that right there. There's a ship. Goes back to that. We are subject to the same thing today. We see things because we believe them first. And in science has happened so many times, of course. The Samuel Ways and they discovered the microscope. You know, before, in fact, there are articles published it's in England. I forgot the name of the journal. They publish how a scientist describes how by looking in the loop, they can see the little humans in the cells. Because that's what the current party line back then, that the human was already formed. It just evolved, it grew, even though the form was already set up right from the beginning. They wrote particles. Oh, yeah, I can see it. Look at the little hand. Look at her. They're smiling there. You know, come on. We know, of course, that that's not possible, right? But they actually saw that. They published that. They were scientists with doctorate degrees and all these things, right? So today, I'm going to challenge you because we have some things that we're blinded today. And they go, but how is that possible? And we'll talk about them as part of the presentation. Okay, last one. To see a world in a grain of sand and a heaven in a wild flower, hold the infinity in the palm of your hand and eternity in 1 hour. That's kind of a capture. I like William Blake for a number of reasons in there. Okay, we're going to talk about today. We're going to start with Big Bang, okay? Which let's talk about it. So with the Big Bang, when that happens, don't ask me what happened before Big Bang, okay? Well, we don't get into that yet. Not yet. We will, but not now. So imagine this so-called explosion. There was no bang because there was no sound, right? But we still call it bang. Anyway, you can see the Hollywood movies, the rockets passing by making the sound. That's crazy, right? There's no sound there. But the marketing people say, we have to put sound in there. I mean, how can you have the experience of something flying in space, Star Trek and all that without sound? You wouldn't sell. So that's kind of the idea. photons and atoms, okay, we're going to look at that, how we look at it from the world, but from the photonic perspective and the atomic perspective. You may say, I don't have the background in science and physics. No, it's beyond that, conceptually. So it's all conceptual. We're going to be how to see the world from that perspective, okay? The problem with the embryology, because we're going to move up to the human being. How do we go from 2 cells to a full adult? When we look at the migration there, then we realize that there's some secrets in there that even today we don't know, but that affects us who we are today. What guides the cells to the migration? But this is going to be a key to understand that it's more than chemistry. And the demonstration we're going to talk about today is going to be about that. There will not be physical contact. I was told, no touching here. We don't touch. We don't hug. We don't do anything. We can keep a distance, right? Now, it's a demonstration. I'll advance you to that because you're going to be pairing. So think about a partner or something that is a particular way of altering the cardiovascular system, the whole body, instantaneously, without touching. And I want you to experience that to see if, wait a minute, all this theoretical stuff, I felt it. When you feel it, then you believe it. Okay, that's kind of the idea. All right, now we're going to focus a lot, of course, in resonance, awareness, and consciousness. Consciousness that's a tricky question, right? Like, what is consciousness? I'll talk about the different current models of consciousness and the one I espouse myself. Okay, we'll talk about it. Let's talk about first how we learn in science. How do we do science? We look at the behavior, we measure things, we measure functions, we observe things, and then we tweak it, try to measure what's happening and see what makes it work, what makes it change. Excuse me. But remember Heisenberg? He says, depends on our method of questioning. So because of that, we have a bias in there that comes in. What we measure is based on what we think is happening. Okay? So when we see this behavior and function, it's based on filters. We have our own filters. And those filters are expressed by the current theories and biases. Some of the biases could be economic. That happens a lot. I'm not going to publish this because I'm going to lose my job. That's happening a lot now. All right. So that means we go down, refine that, based on what we find and what makes it works, then we refine what we understand of behavior and function, and then we tweak it again, trying to understand more and more. This process leads us to a reduction in way of looking at things. Okay? Try to peel the onion, breaking it more and more and more. So now, remember, it was in medicine, which is the one that I'm focusing a lot more. Today, the party line is molecular medicine, right? Let's come up with a new molecule. Everything based on that, and the molecule will tweak something, and will fix things, and will make you healthy. In one area, I take a lot of pictures. I don't know, like photography, to capture things, ideas, what's called urban photography. So one of the pictures I took was on VCU Health, the hospital. See the big sign? VCU Health. CVS Health, that's the other one. CVS, the pharmaceutical. I'm trying to imagine, I didn't do that, but I'm thinking about doing this. It's going in, says CVS, said, I noticed you're CVS Health. I want to buy some health and see what happens. You don't buy that, of course. Again, it's just a name. It's a good marketing name. So it's a lot of equating, Okay, let's keep moving. Sheldrake is one of my heroes also, Rupert from England. He wrote, one of the books he wrote is The Science Delusion. He talks about, in very detail actually, why the so-called scientific process is faulty. There's a fault in there. Goes back to how we learn about nature. Okay, again, it's not nothing new. Heisenberg has said that from way back. Internet connection is unstable. I'm stable. I think I am. Some people may not agree with that unstable, but my wife, you better keep quiet. Look at this one. This is a woman here, a hair. We're gonna move in. That's a 1 hair fiber now. It gives the dimensions. That's 1 hair fiber. Okay, look at the dimensions, micrometers now. Now, but the hair fiber is moving cells and the fibrins, the small fibers inside fibers. Okay, so let's move in a little bit more. After one micrometer, that's very, very small. Inside we have even smaller fibers. Okay, now down to nanometers, that's billionth of a meter, 10 billionth of a meter. Now we can move in a little bit more. Okay, now this is just a human hair that works for everything. Look at this. Those are the molecules that are composing to that microfibrin. All right. But let's look at what's happening intrinsically. They are the atoms, oxygen, carbon, the different dimensions there. But look at this. They're not connected together. So what's holding it together there? Look at the one carbon. Those are the electron orbits, okay? We'll discuss about the electrons. And then inside, that little, tiny little thing is the nucleus of the atom. Tiny little thing. But more than that, inside the nucleus, we still have the more little things, right? The quarks, okay? And that's human hair. The whole body's like that. Everything. Bone, skin, teeth, everything. All right? And that's what's happening. So what we are at the Big Bang, those are the things that were created first. Okay? The baryons. And then because of this so-called explosion, there was a lot of pressure and heat. And pressure and heat, when you put those baryons together, pressure and heat, they form into more higher level particles. Okay? And then the higher level particles, under proper conditions, like in pressure and heat, they form elements. And the first element was hydrogen, which was one nucleus and one electron. Simple ones. And then helium, one nucleus and two electrons. The simple stuff. So most of the universe, even today, it has to be today because the stuff was created at the beginning, still here. It didn't go anywhere. So most of the universe is hydrogen and helium. Okay? There were other particles in there. Lithium was the next one, but the deuterium, the main four things. But hydrogen and lithium and helium are by far the biggest quantity. Hydrogen is number one. Hydrogen, there's hydrogen right here. Now, you may say that's just a human hair. We're going to peel the onion and see reality from this perspective. I'm going to push you to look at it that way and how we see each other from that perspective, okay? Without, again, I don't expect to, we don't need to, no physics. No, I don't have any formulas. No formulas at all, okay? So Big Bang, that's the mainstream today. You ask any, not any physicist, but most physicists. He says, yeah, Big Bang, of course, I have the formulas, relativity theory explains that, it has a beginning, the singularity at the beginning. They avoid the question, what created a singularity? Oh, I don't know. I mean, that's a theological question. Don't ask me. I'm a scientist, right? So, but what about they created fudge factors? Because when things don't fit, you try to make the theory fit into it somehow. And somehow you have to create a fudge factor to make it fit. That happens all the time, even today. Now, what happens is, based on the current physical theory, we know we think the universe, we're measuring that the universe is expanding. If it is expanding and the acceleration of the expansion is bigger and bigger and bigger, something has to be pushing it, okay? Because if you explode something to a certain level, and then it will have the speed or the acceleration will have to decay, right? Because it can move so much, because it's the initial amount of energy is the one that makes the particle move away. And that's it. After beyond that, gravity is less and less and less, so they will decay. But the universe is not doing that. It keeps expanding more and more. Say, oh, wait a minute. That data, we're measuring that, doesn't fit the theory. You know what they did? They created a fudge factor. There must be something, but I don't know what it is, so let's call it dark energy. Okay? And that's exactly what's happening. So there's a dark energy in there. If, then they said, so that, to explain what's happening on how the universe is expanding and the acceleration of that, the dark energy must be so big, which happens to be bigger than all the energies we know about. So it's a huge fudge factor, all right? Huge. It's more than what we measure in the energy. It's about 75%. The estimate, the whole energy of the universe, 75% is dark energy. Okay? So this is just thing as light energy? No, they call it dark because we don't know what it is. Nothing to do with color. It cannot be measured. It cannot be seen. All we see is what the effects on things. All right? But it cannot be measured. So because we cannot measure, do you remember the loop first? Can't measure, you cannot refine the theory. Because so we're stuck in there. They're stuck in there. I'm not. I'll show you how we can get out of it. Okay? So that's what's happening with fudge factor. Even the famous Alberto Einstein, he had a fudge factor. He called the gravitational constant to make his theories fit back then. And today he claims, that was my biggest blunder, because later on we found out that there was no need for a gravitational constant, G. She says, oh my goodness, yeah, that was my biggest blunder. He should have said, my biggest fudge factor didn't work. So yeah, it happens to everybody, happens today, with chemistry, anatomy, all that. This is a fudge factor. I'm going to talk about the embryology, that I know is not true, and that's part of the demonstration. Just to explain to you, wait a minute, this is the assumption, but I'm going to show you, I'm going to break that assumption with the demo. All right, that's another one, astronomy. Planet Y, that was just published a few days ago, by the way. They talk about this planet Y. You talk about planet X before, they skip that, inflation gets up, so let's skip X, let's go planet Y. And that's how they do it. They look at the mathematics, they observe that certain planets are moving not the way we was predicting. So there must be something affecting, some gravitational force affecting it. So there must be, you see what I'm saying, how they work? There must be some object in this position, with this motion and this mass, to affect what we observe on the vibration of the different planets. So that's how we do it. So they start looking, well, they must be in this particular location. This is the elliptical orbit. So let's put the telescopes there. That's what they're doing right now, putting all the telescopes. See, where is this planet Y coming up? So you can see why the astronomers want to do that, because the prestige. Whomever discovered that puts their name there. They became famous, and all these things. So you can see how the psychology behind the scientists, trying to do that. But let's see what's happening. What if the universe had no beginning? Let's ask that question. Well, what's possible, right? And along that line, which is where I'm coming from, no Big Bang, right? Sure enough. Maybe sequential crunches and bangs. Meaning, why not? Because something is expanding, right? Eventually, based on just simple physics, actually, eventually has to stop. But that's an assumption. Eventually has to stop. Why? Gravity. Well, yeah, we know gravity, eventually things have to bring it together, right? Once things bring us together, it becomes a big crunch. And then the big crunch, again, heat goes up, pressure goes up, it gives another bang. So it goes bang, crunch, bang, crunch, bang. So it goes back and forth. And Sir Roger Penrose from England, a physicist, that's his theory, by the way. That we go bang and bang from crunch to bang. And he's developing all the mathematical formulas, how that's possible mathematically. Which I should say, most physics, you have the theoretical physicists to develop mathematical models, and the experimental physicists to do the measurements. The two camps, it's not they're kind of fighting each other actually, but eventually have to come together. So Sir Penrose is on the theoretical physics. His PhD is in mathematics, really, but he was recruited to be in the physics side. So that's what happens. He's a turncoat. That's another one. There's Penrose, Nobel Prize in Physics, by the way. So it's not a rinky-dinky physicist. He's a well-known high up. Check his webinars. He does a lot of webinars on YouTube. Very interesting ideas. Okay, I like his views because it partially supports what I call the panpsychism, which is coming in a moment. Okay, that's done. But if that is the case, then what guides everything we observe in the universe, right? There must be some guidance in there, because the mathematics are not explaining everything. So it must be something else doing it, whether it's in the universe or the human body. I'm going to do both. So what guides the human embryo to an adult? It's the same formula, but same forces for both. There has to be. We are part of the universe. So the laws that apply to the universe should apply to us too. Okay? The answer is yes if we go down to the subatomic level. Okay? Now, if we do that, that may lead us to understand consciousness. More than that, perhaps it may lead us to understand beyond consciousness. I don't go into that, and I'm going to start here. I'm going to use that as a metaphor. Because we are humans, we see ourselves, we understand that, so we're going to experience human experience in a little bit different. Okay? Yeah, it's a different thing. You remember Schrodinger, of course, he goes to a vet, his cat, he was in the bed waiting, cat. The nurse comes out, Dr. Schrodinger, have bad news and good news about your cat. Which one do you want first? That's a physicist joke. In the olden days, computer people, I used to write a big program for NASA. Back then, we used to use punch cards, right? That was again. So that was the old joke back then. This is how do you know which one is the computer programmer if you're playing cards? You see, shuffle the cards, and the just passes out. Right? You can't do that. So let's try to visualize physics, okay? And hence chemistry. Physics drives chemistry, by the way. I know, you see, that's the issue. Right now, in terms of health and healing and all that, it's all driven by chemistry. Everything, pharmaceutical, supplements, they talk about the chemistry of it. Do you realize, then let's look at what makes chemistry change. What are the reactions? What happens in a chemical reaction? There are two things happens. Only two things, by the way. That's it. There has to be a sharing of electrons at the atomic level, or swapping electrons. Okay? They donate electrons or they take electrons. That's it. All intrinsically, fundamentally, let's go down to the basics. All chemical reactions involve those two things. One of the two things. Okay? A lot of them are sharing electrons. So goes back to chemistry is an electronic reaction. It's an electronic. So that's why I said physics explains chemistry. If we look at it from the atomic level, okay, which normally we don't do that. We do, we tweak the DNA, we tweak a virus or something and see the effect. We tweak this, but we don't go into what's happening, what's the mechanism down intrinsically, what makes it work. So we're looking at it too high level, actually. All right. So, for example, what is heat? That's a question. What is heat? Well, no heat, right? It's hot there. Summertime is hot. But what's heat? You touch yourself, you touch your neighbor, you feel the skin is warm. What is that? I know we haven't asked those questions because we just grew up that way, right? You take it for granted. But let's question that, okay? From the scientific perspective, at least critically. Let's critically ask that question and experience. That's just an example only. So what would you say? Well, heat, I don't know, I just feel it. But that's the problem. We just feel it. We put a label. Heat is the experience of heat. Yeah, I know. You feel it out. You touch a hot iron. I know heat. I learned that real quick, right? So we learn that, and we put a label to it, and then we put it in the back. We don't think beyond that. We don't think of below what makes it hot, because that's important. Because now, so then the question comes up: what is the experience of heat? How do we experience heat in the brain? How do we experience heat in the body, in the nervous system? Okay, and then comes the next question. All right, where do we store the perception of heatness? Where is that? It's not always in the hand when you touch, because you don't have to touch something hot to know what heat is. But where is that? Where did it go? So, we can think, well, heat, the label heat, we can think of the brain because we can do a EEG, measure the electrical activity in the brain, and if we experience something, we ask the subject, not patient, but subject, to think of something hot. Is, oh, yeah, I can see more electrical activity in the particular area. More like it will be in the occipital area, by the way. All the vision, all of the data, a lot of the data is in the back, in the occiput. So I say, oh, I know exactly the location. And then you do that with, 50 people, 100 people. And then you say, oh, you know what? I have enough data to say that the perception of heat is in the particular area of the brain that uses a letter with numbers. Okay, that particular location, because it's repeatable. But that's the association of the physical perception of heat, or the imaging of heat, with an electrical activity in the brain. But where is the perception of heat? That's the measure of heat, but the perception of heat is not there. Okay? So let's talk about heat in there. Now, this is just a picture, visible light, photons of light, right? But we don't see this. But what happens if I look at the infrared portions of that? My camera. I forgot to bring. I have an infrared camera left it in the car. For those of you who want to see yourself on the infrared, I have a camera there. Maybe it's a break or something. I can bring it so you can play with it. But yes, this is what the world looks like from the infrared perspective. So that's it. That's the human. We emit that. It's just we don't have the receptors to receive, to absorb infrared light on the eyes. The eye evolved over time to see visible only, from about 400 nanometers, wavelengths of 400, to about 700 or so. That's very limited, 400 to 700. Infrared is beyond 700, long wavelengths, okay? It's long enough that we know the retina and the fovea and the eye doesn't have the chemical substrate to absorb that kind of energy. It's there, but we don't see it. We don't absorb it, okay? Same thing ultraviolet or microwave, you go down to X-ray. We don't see X-rays. It's there, but the wavelengths are too short. And so it's not that it's not there. We have to distinguish that clearly. We're not able to absorb it in the molecular structures on the eyeball in this case. And I wanted to say that, emphasize on that particular area, because the demonstration will break that cycle, that you don't have to touch somebody to affect it. In this case, the cardiovascular system. Okay, so I hope that will be an eye-opener in that sense. So you see what's happening? We're emitting light. Right now, we're emitting light, but we just don't see it. So let me hammer that a little bit, because the demo, there will be a way of emitting photons that are not visible, that affect somebody else. And that's the hands-on demonstration we will do. Okay? But it goes back to this. We are emitters and absorbers of, it's like an antenna. We're like a cell phone. Cell phone, you can send a phone call. That's a radio wave, by the way. Okay? So it's an emitter, but also it's a receiver, because it can receive, absorb radio waves for that particular frequency on that particular cell phone. Each cell phone has its own particular signature, if you will. Okay? Or otherwise you have crosstalk. So if you have your cell phone here, so if well, we have windows in there, but you don't have to have windows to get the cell phone, right? So where is the wave coming from? If this image is all closed, all the walls, you still get the phone call. Where is it coming from? It's going right through the wall. Okay? That's the nature of radio waves. Visible doesn't do that. Put the light in there, it bounces back. Bounces back. All right? But radio waves don't. And many things go right through walls, including the energy I'm going to show you how to use that you are emitting right now. Perhaps some of you may be aware, some of them may not be aware. That energy goes through walls also, okay? Because it's not visible. You can feel it. You can see the effects. You do that, oh, I see the effect. Hopefully that will change the perception of how nature works, right? It's the experience. So let's move on there. So we radiate electromagnetic waves all the time. They're all electromagnetic, by the way. Photons are electromagnetic. Every substance has a specific frequency, all right? For example, gold, 35 hertz. Hertz is pulses per second, right? At the molecular level, they're vibrating. All molecules are vibrating. I'm sure this is all had already. Atoms, they're all vibrating. They're not static in there. Everything is moving, vibrating very fast. Electrons spinning around, I'll give you some pictures of that to kind of just to remind you. Oxygen, 270 and so on. So, human being at the infrared domain, only as an infrared, it's about like a 100-watt light bulb, about that. So it's not a lot, really. But you can measure that. Hence my infrared camera. I use that to show you, the camera is able to absorb, measures the infrared emitters that you have, that we all have. So it's fun to do that. An atom on the skin radiates about 2,000 photons per second. Each atom. Okay, so we're light beings. In fact, I call in other seminar, I call the human body is frozen light, because that's what it is. We have light, we have grown absorbing light over time, and we are managed to capture that into cells and atoms and all that. So it's really frozen light, because the frozen light can affect it. And hence all my work I do with laser therapy, I've been doing that for 25 years now. Yes, light affects physiology, affects embryology, affects the human body, the brain. It's really something. It's just the beginning of what's called energy medicine, right? So what about electromagnetic fields? Let's talk about this. Average body may not be 140 pounds. Yeah, this is about 10 trillion cells. Each cell is about 20 billion protein molecules. See, we have to go to the atomic level to get a feeling who we are. Each protein molecule is about 14,000 atoms on the average. Okay, one atom is about 49 modest particles. Those are the ones I'm telling you inside the nucleus, the baryons, leptons, quarks, and all that. About 49 on the average. Each modest particle contains about almost 1 billion photons. So, if you put that all together, the human body is 1 billionth particle, matter. The rest is electromagnetic fields. Just like the human hair, do you remember? Those atoms are not together, just in kind of there. So what's holding it together? We'll get into that. What's holding it together? Because if we know what that is, we can affect it. Okay? And even hair has that. The whole human body has that. So you think this is solid? This is not solid. It's mostly electromagnetic waves, fields, okay? And hence we can affect that. And some people have developed the skills, okay, in terms of energy emission as emitters to affect what we call inanimate objects, right? They're not inanimate, these are alive. Those things are moving like crazy all the time. We went to a training with Michael Harder, the shamanic training, and that was Connecticut. I forget, Connecticut. Anyway, Michael Harner, anthropologist, he went to Peru to study the indigenous, as this happens a lot, by the way. Abiondo, Carlos Castañeda, they all did that. As anthropologists went down to the jungles to understand these uncivilized people. Michael goes there, his PhD in anthropology, and he learned enough about the indigenous way of understanding reality and working with it that all different realities. So he liked so much, he believed it so much that he stayed there. He was there for over 20 years. He never came back. But he came back after he was fully trained, because he said, his teachers, basically, his shamans, he said, go back to the U.S., help people understand more. So he formed what's called the Shamanic Foundation. And he had training classes. He passed on already. But he had training classes, and we went to his class, maybe, I don't know, 30 years ago, something. He wrote a book called The Way of the Shaman. Really interesting. Part of the exercise of being training under Michael Harner was the ability to, see, the language doesn't help, converse with rocks. You're not talking to a rock, right? But you're engaging a rock. Like it's engagement with a rock. And you can get, the rock is not talking back. It's just allowing you to realize certain ideas, so I guess we can call it that way. It's a conversation, quote unquote, with a rock. So they're not inanimate. Well, the Native Americans have said that for a long time, right? Lakes and rivers and mountains, they're all alive. And that is true. You read about Carlos Castaneda's books. I forgot their title. He has several books in there about Yaqui Indians from northern Mexico. It's the same thing. Okay, let's move on here. Careful about the word quantum. It's been abused a lot. Unfortunately, it's confusing people. And this just came up just very recently. Webinars and books on this, the quantum self, quantum leap. What was one book titled Quantum Leap. If somebody talks about quantum leap, that means the jump is very, very small. I mean, because a quantum jump is just tiny, tiny, tiny. But when they write it's a quantum change. Oh my God, quantum change. What? That's nothing. Quantum change does nothing, because they're abusing the term. The marketing people just got out of hand, basically, confusing people. And that's one example. There's so many of them. That just came out. It's a webinar coming out very soon, I think in the next few weeks. Talk about the quantum heart-brain connection. Now, quantum works at the quantum level. That's at small subatomic levels only. Okay? Quarks, leptons, not the brain or the heart. Maybe coherence, perhaps, but not quantum connection. No, it's none. Okay. But what can I say? Don't get me going on these things. But let's go back to the beginning. Beginning, of course, we all know Adam and Eve, right? Oh, gosh, it's too small. You can't read that. Let me read it for you. It says, this is Adam. When God created in his own image, actually God looked much better in person, but she didn't own a good mirror. So that was Adam. And then Eve came up, of course, this is Eve, and who was created from Adam's rib. This gave him an awful pain in the rib on the side. But later on gave him an awful pain in the neck, but that's a different story. So you can imagine Adam at the beginning, right? He ate the apple and the snake was there and all this stuff. And apple, they saw the nakedness. So Adam went to the bush, got one leaf, put it on there on the proper place, and they was happy, uncovered. Eve is in the bush, is in there. There's nothing to wear. There's nothing to wear here. Where do I go? Nothing to wear. No? So that was the beginning. And then things develop differently. Brains are different. Man, on and off, and that's a very simple brain, really. Women. I remember you did that to me 31 years ago. Okay. Things haven't changed much, over time. Still, it's a different thing there. So kind of I still no change. Right? I don't know if you can read this. He said, for the last 30 years, all you have done is find my mistakes in anything I say. 31 years. And that one says, my one female intuition is so highly advanced, she sometimes knows I'm wrong before I even speak my mouth. But you know, the female brain has developed how many advantages really. So you can see there, you know, we're looking for someone who can do the work of two men. Oh, it's only a part-time job. And but how do we quench that? How do we bring it down, right? Because the powers to be now tends to be more male oriented, and with financial, economic, politically, militarily, you know, tends to be more male, as opposed to the Amazon back then. You know, that was different. In the jungles of South America, the Amazons were in charge. And anyway, it's a different story. But this is how, you know, look at the training, what's happening now, right? But you see what happened with women. That's so we form them. So that's how we kind of try to erode that advantage. And that happens a lot. You know, look at this. In marketing, like I told you, I had a gazillion photographs and captures, ads, advertising. This is an advertising. Always showing the male in charge, knowing, guiding, all of that. Mixed. Listen. No? Okay. Has been going for a long time. There was typical ad. Look at it. You mean a woman can open it? That was an alcohol aluminum. They made a cap, you know, for the ketchup. Yeah, that's happening. Look at this one. They're selling a projector. And if you read, you know, the caption says, yeah, she's gonna show you the projector. Okay, emphasis on that. And that was an ad back in the beginning in the 1950s. This is very recent. I just got it a couple of weeks ago. This is a multinational corporate brochure. And why did they put the woman there with showing the breast in there? I don't understand. Look at this. This is the top executive in the company. I go, what's going on? It's so subtle that people don't notice. My mother trained me kind of to be critically about certain things, gender issues. That was my mother doing it. So now my brain says, I can see things a mile away. Why is that? Kind of, that's what started all these things. Recent book, you can get it there. The New Age of Sexism. They're using AI now for that. You see a lot of strong bias in that. So subtle, you know, do you remember Barbie, right? Somebody built a proportional Barbie on a human scale. That's what she would look like. And I know enough of the human biomechanics. She couldn't walk. She would fall forward. No way. Unless she goes like that, you know. Anyway, I highly recommend to check this TED Talk by Paula Williams. She was a man before. She was an executive in companies, made all the perks of business, and then changed her heart. Well, he changed her heart. He was changing all the things too. So he becomes a woman. He was a talk about her experiences as a female compared to the experiences she had when he was a male in business, in traveling, in flights. It's an eye-opener. I like that a lot. It has been a few years ago. Paula Williams. It's a TED Talk. You can find it on the internet. It's not just women putting down. Look at this. Ben Houston, 1950s. He says 4 out of 5 men prefer Van Heusen shirts. The only oddball is an indigenous from Africa. It's interesting. Now it's still going on right now. Let's go back to embryology one more time, okay? I'm going to peel the onion now, get into how we got to this point. So the question is, 2 cells. Oh, but you know why we have a lot of sperm in the one egg? Very simple, you know. It's just men never stop to ask for directions. So that's why we have to have. So from 2 cells to a human being, let's focus on that a little bit. When they multiply more and more, what guides them to go where? It's again, you have to be yourself. You're a cell there, okay? You're a primordial cell. You don't have any affinity with anything yet at the beginning. There's nothing, no bone, no skin, nothing, right? You're a cell. How do you decide to, oh, I'm going to be a bone cell? And the other said, no, bone cell, oh, that's so passe. You know, I'm going to be a nerve cell, right? How do you do that? What guides them to do that? Nobody knows, by the way. There's some theories. Yeah, well, there's some theories about that. But we'll talk about that. Mainstream migration model, it's called migration models. Chemical guidance, chemotaxis. Oh, chemistry guides them where to go. But where's the chemistry coming from? Oh, well, something shows up. Cell matrix interactions. You know, they always kind of, it's a fuzzy cell-to-cell interaction. Physical contacts, meaning a bone cell, if you're a cell that is emerging, a primordial cell, a stem cell, if you're touching me, more like you become bone cell also. But what about the first one? No. Gene regulatory, back to genes. Oh, the DNA does it. No, DNA is just a bunch of molecules. It's not a program, okay? Mechanical cues, morphogenetic factor. Well, there's a shape of that. Electrical. Well, they all fail. This is graphically what's happening there. But they all have one common thing, one common property, all these theories. They all rely on molecular, mechanical, or environmental factors. They don't explain all this stuff that happened. That's not enough. And I'll give you one example of when I was in chiropractic medicine school. I was puzzled because, I wanted to understand the human body, right? There's a gross anatomy lab, all these cadavers. Oh my God, to me it was a feast. Going, oh, I want to cut here, open this up, I want to see what's inside, right? So I was just like, in fact, I became a TA for the gross anatomy lab on purpose, so I can be there with all the bodies and kind of doing the dissection. So that was my puzzling question. And that's what guided me to work on the gross anatomy lab. I never found the answer. I keep looking. Do you remember the cycle? You know, you observe, measure, right? Measure, go, trying to find an answer to that. Can't find the answer, go back. You know, but then you have biases as to what's happening. And I knew the biases and the current theories were not explaining what I was trying to looking for. So let me give you an example of what I did. So it goes back to the, so still looking and focused. Let's look at the eyeball. This is just one example. There's so many of them. I have not enough time for that. Let's focus, where is here? Here? No, this is, by the way, this is an emitter, right? That's an example of emitter, red light. This is a receiver, absorbs light in certain wavelengths. Watch this, no light, absorbs it. Just goes back to that. So you can't see it. It's there, but you can't see it. That's the nature of the LEDs in there. Anyway, so I have to do it manually. So let's focus on what's called superior oblique muscle. That's the muscle that allows you to go down and out. So if you go like that, you're activating that muscle, okay? Down and out. So let's look at how the muscle is doing, because the muscles attach to the eyeball and then attach to bone on the other side. And uses like a lever, okay, to move the eyeball in different ways. So, for example, the lateral rectus allows you to go lateral, like the name says, right? Lateral rectus is straight. Lateral, so you go to the side. You know, you're going like that. You know, that's one particular nerve doing that. Cranial nerve number 6, for example, gives a lot to do that. But going down like that is the. Let me focus on that one. That one is an oddball. The superior oblique. So. Now watch on this. Oh, I can't show it. Point it. I'm stuck in this corner. I'm not used to this. You have to look at it right there. You see this muscle, okay? It's attaching to the eyeball and then has to attach to a bone. So it uses a fulcrum to, when it contracts, it moves the organ, in this case, the eye. So that's what the muscle, you see the curve up on the upper right, goes to the bone. They call the sphenoid. Don't worry about that. Don't worry. It's just goes to a bone, okay? On the socket. So when it contracts, it moves the eyeball down and out. But do you see the little ring that is around there? That muscle goes through the little ring and then turns and goes to the bone, to the sphenoid. So using the ring as a fulcrum, okay? Like a guy wire, like when you have a boat, build a boat, they have to use something to hold it, and then you pull, right? Like a pulley. So that's why I call the muscle and the pulley, or trochlea. In Latin, it's called trochlea. So my question was, from the embryology, I knew about this muscle. I went to a gross anatomy lab. I want to find it. But we didn't have fetal cadavers, so I couldn't find the young cadaver at that point. So they were mostly adults or teenagers. But then it's already formed. I wanted to see something at the beginning. Where is that little muscle? Where is that little ring? Okay, before they finish forming. So that will be on the fetal. It's about week number 12. 12 weeks is when it forms. Before then, the two things are straight. The little ring is straight. It's cartilaginous. It's not bone, cartilaginous. So imagine this as cells. They're called chondroblasts. They're on this little pulley, but at the beginning they're straight from the embryo. So imagine the cell moving on straight, elongating the cartilage, right? The muscle was the same way, going straight. And then suddenly, and this is the question, suddenly the ring, the pulley that was straight, began to turn to make into a circle. So my question, what's making it so? Wait a minute. Cells don't have intelligence. They can't plan ahead. So, well, I'm going to do that because our neighbor's going to go through us and use this as a, come on, give me a break. No, not such a thing, right? I couldn't find it. So let's focus on that's the trochlea, okay? So if you want to search on the internet, they use the term trochlea, pulley. So let's look at from a different perspective. There's a muscle. You see the ring there, okay, the cartilage. I never found it in the gross anatomy lab. So let me do research. People have done research on purpose to see the embryology of that, okay? And the best article I found was this one. Early fetal development of hard tissue pulleys, which is the trochlea, for the human superior oblique and the tensor velite. That's another muscle that has the same issue. Crazy stuff going on there. Let me show you what it says. Embryologic studies show that there's a section I want to choose. Okay, the insertion of the tendon, the cartilaginous pulley, and the muscle are straight line first, and around week 12, the tendon then begins to turn and go. That doesn't make sense to me, right? To me, it's like driving in a pothole. I go, pothole, what? What do you mean begins to turn? Are you kidding? And that's the best I could find. What tells it to turn at the right time? Nobody knows. So my question is, so what guides those cells to turn at the right time? So that's the question. And then I had to go beyond what we normally know about embryology, anatomy, physiology, and all that to come up with an answer. And that's what leads me to the non-chemical answers. That gets me into what's called Kirlian measurements. I'm skipping a lot of stuff because after 6, 11, 20, we're right on time, yeah. I saw this organic mushroom on a Kirlian photograph. And then I saw the commercially mushroom, same Kirlian photograph. You say, wait a minute, why is that the difference, right? This is a plasma discharge, by the way. If you're into physics, you can measure from the plasma level without emitting plasmatic energy, okay? And live or dying. Dying, you can see it can diminishing. Gets to a point that it's extinguished, there's no light at all. But that was commercial. Same thing with a leaf. See the leaf, the corona discharge. And but when you mutilate the leaf, it's still there for a while. And then it decays and then it shrinks to nothing. So that's a process of dying. And I'll show you in a moment later on a physicist from Russia who spent a lot of years measuring people dying, the process of dying. And he wrote a book on that. It's coming in a moment. He wanted to do the same thing. Oh, he built these things. Yeah, Konstantin Korotkov from Russia. He built this machine. I started working with him trying to get the FDA approval for his machine in the U.S. and now it's sold under some other ways. But imagine this: there are killing cameras inside and measuring what's called the coronal discharge in the fingertips. Okay, and this is one example there. That's what it looks like, one finger, and that can be used for diagnostic purposes also, because when they combine all of them together, you can have that composite of the whole body. Okay, and that was his product. Yeah, we have time there. Let me tell you how I met Constantine long time ago. There was an investor in Long Island, in New York. He hired me as a consultant to check on this Russian guy coming with some strange idea. This is probably about 30 years ago or so. He said, but he's asking me to invest in his company, his invention. But I don't know anything about physics. I don't know anything about medicine. You know, can you help me out? So went to his house in Long Island. Beautiful, huge house. I mean, very wealthy man. Anyway, Constantine shows up. Short man, bald head, really good. Eyes are shiny, really kind of very penetrating. And other people, Link Wisniewski, which I'm going to introduce. He was the medical doctor working with Constantine. So that's how I met them. Anyway, I'm staying there. We had a weekend private conference. Constantine talked about, you know, the physics of that, how it works. And Link Wisniewski is American side. He's an American medical doctor, talking about the potentials of medicine, giving a pitch on the investor. He said, we need your $3 million, you know, from your pocket. Anyway, they left. I stayed with my friend there, the investor, to debrief, right? And then he gets a call from the hospital, but then it was Monday already. He said, your grandchild is in the hospital with severe headaches. It's a really bad time. No, it was his daughter. He said, so-and-so, the nephew, is having terrible headaches. It's unbelievable. He said, no, then my consultee, he said, bring it here. We have this machine. Let's just try it out. He tries the machine there, and he said, boy, I feel something really strange. It's a big gap. Imagine a big gap on the brain section, okay? And he says, maybe I'm not doing it right. He does it, again, this guy, he's not a medical doctor, he's not training anything. He's just going through the same steps that he learned over the weekend. He does it again, did it 3 times, got the same hole on one side of the brain. I don't understand this. This doesn't look good. He calls Len Wisniewski, who lives in Colorado. He said, Len, this is the problem. What am I doing wrong? He said, okay, let's go step by step. Do this, do this, do this. He found this. Send me that pictures that you're getting. He sends it over the email to Len Wisniewski. Len looks at it, says, get your grandson to the nearest neurosurgeon fast. And again, this wealthy man, his connection, he can buy anything really. He got a neurosurgeon the next day, right away, to do the surgery. They found a huge tumor the size of an orange in the brain. That's how I met Constantine Karate. So I said, wait a minute, how did this find some anomaly like that? Okay, and that's what, again, 30 years, it sort of cemented in my mind that maybe there's a science behind it. This is a PhD in physics from Russia who has been doing that. He said there must be something. That's what got me started learning more about what is this coronal discharge? What is it measuring? Where is it coming from? How can we use it? Okay. Instead of coronal discharge, I use lasers. So this is when we met back then, long time. God, no gray hair. That's Sharon, my wife, here. That's Constantine, short man, bald-headed man, and that's Len Wisniewski right next to him. And I'm gonna come to about Len, in a moment why. But Constantine had written several books, and one of them is the human energy fields. Goes into how this works and all that. And I have a deal for you. I can give you an electronic copy of the book. It's about 400 pages. There's all the theories behind that. Can give you an electronic version of that. How much is we can pay IONS? They have to donate to IONS, right? About $750 or so. No, it's Janet can help me. You can pass this out. give me your name and email address, and I'll send you the electronic version of this book. No cost, so just to learn it. Okay. This is the one that Len Wisniewski wrote. Is the scientific basis of integrative health. This is looking at all different aspects. I wrote chapter 10 in lasers on this, light and lasers, but discuss all different things from electromagnetic fields, homeopathy, Kirlian photography, and all that, all in one book. And that was Len's contribution. Same thing, write your name in there. But what else guides cells as they migrate? Electric fields, for sure. Bob Baker did. Okay, I can't. Bob Baker, medical doctor from New York, NYU, did a lot of research on how electrical fields can guide the migration of cells. Okay. Anyway, so that's an old book, Body Electric, 35 years, maybe 40 years ago. He had written several books. Most of these people lost their job. Bob Becker, after he published this, he lost his grants from the NIH, and eventually he was kicked out of the university from research. Oh, happens a lot. I'll show you some other example. Bjorn Nordenstrom. Long story short, Nordenstrom. Nobel Prize. Do you know where the Nobel Prize comes from? It's the Karolinska Institute, okay, in Sweden. Nordenstrom was the head of the committee that selected Nobel Prize winners in medicine. He was training was a radiologist. Before that, he was an electric engineer. So he had a little different way of looking at things, right? Electrical, following this kind of ideas. Before Becker, actually. Anyway, he wanted to publish. Yeah, 11:30. Okay, let me tell you what happened. He, as a radiologist, was focused a lot on bronchogenic carcinoma. He looked at the tumor, and then as an electrical engineer, he looks at, you know what, that's weird. Why is the tumor electrically positively charged? The body is supposed to be negatively charged. He said, but that tumor is positively charged. That doesn't make sense. Well, why? Look, he did, as an electric engineer, said, you know what? If it has to be negative, I'm going to force it. I'm going to zap it in there, put two probes, the anode and the cathode, run current through it to force it to be negative. That's what he did with patients. Lo and behold, the bronchogenic carcinoma shrunk to nothing. Say, wait a minute. We had to publish this thing. Everybody has to know that. Cancer, lung cancer is pervasive and all that. And this is cheap stuff. That was the problem. It was too cheap. Put electricity and zap it. It has been published so many times and nobody will touch it. He's head of the Nobel Prize Committee to select the prize winners in medicine. Prestigious person, right? Nobody will publish it, no journals. He decides to publish himself. He published a book, and the third circuit in the body. That was the title. He goes into all the studies, all the research, the experiments he did, because nobody will publish the book either. He did it himself. I bought a copy of the book when it came out. You go search on the internet, Amazon, nothing showed up. Nothing at all. None. I say, why? Why is the politics coming in? And yeah, even today, right now, it's happening right now. So Nordenstrom, that's another one that got me going in this direction. So let's back to this atom behavior. Electrons are not really balls running around. I think we all know that, right? It's a cloud, and we got the Heisenberg stuff. You remember the cloud probability and where it's supposed to be and all that stuff. And you have hence the uncertainty principle, right? But that's what it is. It's a cloud. Nucleus is very small, very, very tiny. Let me give you sort of you see, the problem as humans, we can't relate to things that are too small or too big. We're sort of in the middle. So imagine the nucleus is a dime on the floor. And I don't have any money. Anyway, imagine a dime on the floor, okay? The electron cloud is about the size of a football field, okay? So the dime is the nucleus, that size. If that is the dime at that size, the electron is flying around, vibrating at about the size of a football field. So the question is, what's in between? What's holding that electron from spinning off? Because it's spinning really fast, right? As a cloud. So you think if you get something, a wire with a piece of metal or something, you spin it, you let it go, centrifugal force would have to eject it, right? So what holds it in place? And then the two atoms come together, they interact in different ways. In fact, the DNA, okay, let me just finish about the electron real quick. The electron is key for the matter. All matters have electrons, as you know, they're vibrating a lot. Same thing for energy, okay? Electrical energy in this case. That drives the basic of physics. It's all electronic at this point. Biophysics, in particular biophysics, and that drives chemistry, like I described before, including biochemistry, which is my main interest, really, biophysics, the interaction of the two, How does that apply to biology? And if you put that all together, you have all these ologies. They're all based on this guy, electron. If you look at pathology, physiology, all the ologies from the electronic perspective, you have a whole different way of solution, different ways of handling the pathologies. So this is the electromagnetic wave. You have an electric field and a magnetic field, okay? So that's what we call electromagnetic wave. And you cannot separate it. So it's all together, okay? I have a seminar called Bioelectromagnetic Medicine, really. It's a 4-hour seminar. Maybe some of the time we can do that. An example, the photon, that's an electromagnetic wave also. All the energies in the world, in the universe, is electromagnetics, by the way, everything, okay, in different forms. You remember this hydrogen atom, there are different atoms there, but they are really clouds. That's what they're working together. So in this case, they're sharing an electron at the bottom. So imagine that. But now let's apply that to a guy from France called Benveniste. This is the current party line, even today, by the way. It's called the structural matching. For a function to occur inside the cell, we have to have some sort of a ligand and a receptor. It's like a key and a keyhole. It has to fit in precisely for a function to occur inside the cell. That is today's cell biology. Benveniste discovers, wait a minute, there's more than that. I can use electromagnetic fields to affect the function of the cell. Do you remember that little circle, how we learn nature, right? It's like that. This is our bias today. We're biased. It has to be a molecule doing that, an enzyme or something triggering it. But Benveniste said, no, wait a minute, there's more than that. Let me show you. Did the experiments. And this is one of them, really. He was in France, connecting a beak of water in France and affecting the composition of the water in Chicago, that's right, yes, remotely over the internet. Okay, see how that experience has been done so many times, really. William Tiller has done it, Radin has done it in IONS, and he's just overdone all the time. But how come science hasn't changed? Politics and economics. Chemistry still drives business. So that's the reason we don't do that. So another reason is this experiment validated the memory of water, which is the foundation of homeopathy. Oh, wait a minute. I can't go into that, right? No way. It's blocked that. Stop it. Yeah, he lost all his researchers, like Nordenstrom and Becker. Something happened to him. So yeah, and let me give you just a little view of this. Look, Montagnier, he's a Nobel Prize in physics, actually. He's a medical doctor, but he got it in physics. Look at what he says. I'm told that some people have reproduced Benveniste's results, but they are afraid to publish it because of the intellectual terror from people who don't understand it. I don't agree with it, don't understand it. I think they understand it. They just understand the consequence, political and economic consequence. That's, another big guy. He's not, some rinky-dinky scientist. Yeah, let me say that, right? Because of that. Yeah, Benveniste also has several videos. There's one by Luc Montagnier. Oh, that's beautiful. Check on the internet. There's a video an interview with Luke. Amazing how he described how things work and all that, right on the internet. So let's back to this human body. What is this energy that Benveniste and other people were looking, Konstantin Korotka were looking at that? There's a shape for that, okay? So let's go to the human field and interactions. That field, in the demo, we're gonna alter that field, and there will be an effect physiologically, okay? And that's called the Nogier vascular analog signal. Nogier was a neurologist from France. So we're going to use the radial pulse shape, not the pulse rate, the pulse shape, okay? Right now, if anyone's interested in searching on that, Paul already passed on. His son, who's also a neurologist, Michel Nogier, he runs the group called GLEM, G-L-E-M, GLEM, ongoing right now. Has been going on for many, many years, actually. Or you can also check, I forgot the psychiatrist's name, Andrew. He's a psychiatrist in Santa Barbara who is in the US doing a lot of the seminars on how to use this medically. And we did some joint seminars, Ackerman, yeah, John Ackerman. He's a psychiatrist from California. Also, you can search on that. He has written a number of articles also, John Ackerman, on this Nogier, how to use it in medical field. All right. So this using the autonomic nervous system as an antenna to radiate, to create coherence or discoherence, either one. So we're gonna do the hands-on. We're gonna pair. The way to do it, I'm stuck in this corner, so I can't demonstrate. But the way to do it, we're gonna use the radial artery. Okay, if you do the radials, if you go to the radial close to the wrist, you see a little bump. Okay, it's called the styloid of the radius. And right before the stylus, if you go down to the center, there's a depression. You go to the radius, the radius on the thumb side, okay? If you go on the bone there, if you move towards the other side, there's a depression. Okay, that's where you find the radial artery, okay? So you're gonna feel it. Let me show you a picture here. Let's see. Yes, related between the human hands. It's another experiment. I'm sure you have done that. Put the human hands, you feel the heat and all that. It's kind of similar. It's that idea. So we can use that to measure the effects on the biofield. What affects it? In fact, medically, you can use it well. How foods affect the Nogier pulse, or thoughts, intentions, devices, memories. Okay, all that. That's how Nogier developed it. What's called auriculomedicine. Auriculum means ear. Ear is the best antenna we have, really, by the way. Why? I'll show real quick. It's the only item of the body, embryologically, we have three main cells, three main layers, germinal layers, okay? There are three. All things come up from one of the three. Bone, skin, nerve, all that comes up from one of the three. The ear is the only part of the body that is accessible that comes from the three layers at the same time, the ear. And there's a vagus nerve in particular that comes to the lobe of the ear, okay? Very powerful nerve for being parasympathetic. Anyway, so the ear is the best antenna because it can talk to the three layers, the germinal layers. That's why Nogier, as the neurologist, said, hey, let's focus on the ear. So he developed the whole auriculomedicine based on the ear as an antenna. The two aspects, auriculotherapy, which is doing the tooth pain issue, locomotion, low back pain, whatever, or auriculomedicine, fixing pathology, changing pathology. So there are two different fields. Anyway, so back to this. And look at this here. You can see the thumb is opposing the flow of the blood. It's not checking like the pulse rate. Nothing to do with rate. So you can see how the thumb is facing the pulse coming, hitting your nerve. And Nogier actually discovered that the outside of the thumb is the best, most sensitive to the pulse shape. Okay? So that's how I do it. I do it like that. And I'm very gentle. If you press too much, you're collapsing the artery, you don't feel anything. So you're very light. You can do it, you can do it yourself, but somebody else has to do something to alter the biofield. You see, you can feel your own, right? And if you feel your own pulse, I'm gonna suggest for your neighbor to do something, and you pay attention to your pulse shape, okay? And then say what you feel, what you find. I don't want to put words in your mouth, okay? But remember the biofield we talked about there? So I'm going to ask somebody else to do something, which means that interferes with that biofield, and it shows up a change on the pulse, the notional pulse, okay? So you can feel it yourself, or you can feel it to your neighbor, either way, really. In the office, what I do is I'll use that pulse there on the patient, and then depends on the history, what's happening. Maybe it has a knee replacement, I'm still in pain, I can't move, whatever, okay? Then I go to the knee area that is perhaps symptomatic, maybe a real cause or factor, and then just hover over it, and that will change the Nogier pulse. So I'm going to demonstrate that to you, how you do that. That's how Nogier taught me how to do it. So you find your own pulse. Because you're feeling your own pulse, somebody else has to interfere with your biofield. So you have to have a second person, okay? One area that we have a very strong antenna, which is the part of the autonomic nervous system, is right here, okay? You can call it chakra and all these things. They're all connected, by the way. Plexus, the plexi of the autonomic system maps very almost identical to the chakras, which is a whole different lecture. So it will be right here on the sternum, okay? So you're gonna feel your pulse if you wanna do it to yourself, but somebody else had to put their hand near, not touching, only near that area. And if you're feeling your pulse, feel any change, anything happening, maybe nothing, okay? You can go ahead and do that. So how many people want to feel their own pulse? Okay, so you can feel your own pulse, you're doing your own pulse. Then you have to ask somebody else to put their hand without touching, just in the area near the sternum. Yeah, without touching. Make sure you feel your pulse first, quietly, without pressing too hard. Then ask your neighbor to put the hand on. No touching. You don't need to touch, no touching. You could touch it, but you see, the message is really that you have to be physical contact. Yeah. Any, this, yeah.
Doesn't your thumb have a pulse too, though?
Excuse me?
Doesn't your thumb have a pulse?
Yes. Yes, of course. The thumb has a pulse, but when you feel your own pulse, on the interference of the biofield, both of them will change because it's a systemic change. Good question. When there is an interruption in the biofield, this is not the only place that is changing. It's the whole body is changing at the same time, systemically. So it's not just one area. Okay. Can you mention? Yeah. Don't press too hard. Okay. You have to feel the. Yeah.
Is it the person who's checking the pulse is supposed to feel, or the person sending?
No, there are two people. One person feels the pulse, and the other person does the interference, separate. Can you any observations there? Yes. Okay, good question. Yeah, he said, I felt my pulse got stronger. Anybody else? Yes? Increasing or down? Oh, you felt your own pulse. I see what you mean. Yeah, I see. Okay. Yeah. Anybody else in there? Yeah, she's doing it well. No contact, that's right. Can you report back in there? Yes. Stronger too, I see. Yeah, I see. So in this case, you see sometimes the pulse can flatten. And in fact, in some cases, some people wrote, what happened? I don't feel any pulse at all. Like, are you alive? you know, uh, the effect is temporary. It should last only a few seconds only. So don't worry that you're gonna pass out or something. You know what I observe all the times? This is the first time that I notice a group of people that nobody has jumped in and says, what is the meaning of this? Yeah, they all turn to discover, oh, wait a minute, what does it mean? And they miss the experience, the fact that you didn't have no physical contact and you're changing the cardiovascular system systemically, all in one shot, like a switch, on, off, on, off. You can switch, nonstop. Works with animals too. You can do that with a dog, a cat. They respond. If they're alive, they have an autonomic nervous system. They have an antenna, they call bioantennas, and that you see the effect also. Horse and all that. But this is, yeah. Question?
I got a microphone over here, Frank.
I can repeat the question, yeah.
What does this speak to the brain?
Oh, you see that? What is it different? Yeah, let's get into that a little bit. Yeah. But let me, this is how it's done. This is from pictures from Noyer. What's happening now? But you see, there's the different ways. You can change the rate, the press is down, the rate can go up. In this case, this is flattened down. They have different meanings as part of the auricular medicine diagnosis. This kind of don't want to get into that. There's a guy in Canada called Smith. I don't remember his first name. He has also training classes using the ear. He's not a medical doctor. He does therapies, and he uses filters. Watch on this one. What he does, homeopathic remedies on filters could be what's called nosodes, meaning tissues, embryological tissues, bone tissues. Sometimes somebody has, let's say, a tooth infection. They can take the infecting material, the crosses of the gum, and put it near the ear to be able to detect what's happening there. So it's a lot more than meets the eye. It's just yes, question?
So if I'm standing in the sun in the morning and I have my bare feet on the ground and my feet are a little damp, and what does that do to my mitochondrial DNA, and how does that increase my my charge?
Yeah, increased charge. Okay, like I mentioned before, the body's normally supposed to be negatively charged. Okay, the Earth also is a grounding entity. But look at, we're using floors, rubber soles. We're driving cars with rubber wheels. We're not in touch with the Earth anymore most of the time. Carpeting, second floor, all these things, right? Gets in the way. So we tend to accumulate positive charge. We end up being too positively charged. And that connects to pH, by the way. Okay, positive charge makes it acidic, low pH. Let me give you another tidbit. There's so many things, unfortunately. If you look at the malignancy, cancer cells, okay, tissues, they all have a common denominator. They're different kinds of cancer, many different kinds, okay? But they all have one common denominator. You know what it is? Yes, low pH. Like Nordenstrom found, it's low pH, positively charged, and it's supposed to be negative. Can you intervene, like Becker did, to force it, or Nordenstrom to force it to be negative, and that has a pathological change? So indirectly, you can surmise that helps you balancing your health by charging yourself to negative. The Earth does it too, of course, but we're getting in the way ourselves. Yeah, good question. Yeah. Yes.
Back to your comment about things transmitting through. The idea that I'm on the second floor or I have a floor or a carpet, it's a bias.
Yeah, okay.
The word
okay.
transmitting.
So we're getting how do we manage that? Very simple, really. Any grounding will help you. So you can have a grounding mat, okay? All you do is something that is a conductor, a mat. Yeah, that will do it, but that takes practice and skill to do that. It's cheaper and faster. Anybody can do that. There's an electric mat. You connect it to the ground on the outlet. That's it. You step on it, it grounds you. Yeah, you can go outside in the rain and do these things, go naked or whatever. I don't know. That's it. But this is cheap. You can do it at home anytime. And you can buy one. You go to the internet, grounding mats. But why pay one? A conductor mat, put a wire to it, make a hole, put a speaker wire, and put a plug on the other side, connect it to the ground, not to the positive, just the ground on the outlet. And that will do it. At home, for example, we bought this beautiful bed. It's metal. Okay, guys, it's all Italian shape and all these things. Before I knew all these things, very nice looking, it's all metal. Okay, forgot the name, metal. Nickel and brass, that's right. So what I did now, once I learned these things, I drill a hole in the frame, got a big thick cable with a nice gauge, and connect it to the ground on the wall. So my bed is grounded. For that reason, I don't fool around. Once you learn all these things, you go, well, I don't drink water. Anyway, it's a snowball. You start taking care of yourself differently. A question, comment? Yeah.
So when you talk about the pH, can you hear me? You got it?
Mm-hmm.
The pH of the body, are there different pHs
Yes.
all over the place?
Yeah, different.
And
different
can you measure?
Quick formula. The saliva pH is correlated with intracellular pH and also extracellular. So you can, depends on how you look at it. So there's a particular way of using saliva pH and urine pH to infer. There's a connection. Saliva pH tend to be 1 degree more acidic than intracellular. So you can use saliva in lieu of cellular pH, which is expensive to measure. Urine pH is 1 positive. So that's for extracellular fluid. So there are ways of kind of working around that, yeah.
So are you saying that if you get cancer, it's every cell in your body is at the wrong pH?
Oh, I see.
Why is it that it gets stuck in?
I don't know. Let me just describe what was found by people who are more expert than I am in that area. Like Nordenstrom, for example. He found the charge was on the tumor itself. So Becker calls it the wound change of polarity. Well, he found very quickly, he found that when you have a wound, for whatever reason, surgically or traumatic, whatever, the polarity of the wound changes to positive, the wound itself. You cut yourself, that becomes positive on that location. Can you induce healing by that, by putting electricity? Yeah, that's exactly what Bob Becker did for many years. Yes. He managed to, amputees, children, as you know, children at a certain age can still grow fingers when they cut a finger, right? He managed to accelerate the growth rate, okay, and extend the age. You have to be fairly young to be able to regrow your fingers. But he managed to extend the age by using electrical currents. Wow.
That's crazy.
Yeah, so that's why I called the book was body electric. That's,
Can you explain how the Lumix laser works to manage pain with these principles?
Yeah. You inject an anesthetic or something.
I'm sorry? I didn't hear what he said.
Inject anesthetics. No, that's a load. It takes longer time. I've been checking the time. Light. Okay. Very short question. Short answer. All cells, except one, all cells have inside has a little organelle called mitochondria. You mentioned the mitochondria. Inside the mitochondria, there's a particular molecule that is able to absorb light. of certain wavelengths only, okay? So if the laser is able to penetrate to reach the mitochondria, when they absorb the light, is able to produce more molecules called ATP, which is the energy of the cell. So with that energy, ATP, the cell can reproduce better, fix repair, change function, whatever the cell was designed to do would be a better cell. His hepatic cell would be a better hepatic cell, cardiac cell, skin cell, So that's how there's an effect on physiology and pathology. So that's kind of the short version of it. There's more to it, but that's one way. Yeah. So the bottom line is the light has to reach inside the tissue. But remember, visible light doesn't penetrate. So it has to be an infrared light to do that. At least that. Let's move on, because I'm concerned about the time. Good questions, really, but that I'm over 25 years. Like I mentioned to you, a few people ask me, what are the mechanics? How does this work? That happened here. Very few people. Most people end up trying to say, well, what is the meaning of that? How do I use it? Yeah, which I understand that. We want both. But most people end up like that. In fact, the more medically oriented people, more like that. Yeah, okay. What do I do with it? I'll tell you about the chakras and the nerve flex. There's a high correlation between the two, really. That's how we're working with. I don't want to use the word chakras because it's a loaded term. Some people unscientific and all that. Even though it has been measured in France, I don't remember the name, they injected radioisotopes into an acupuncture point and they map how the radioisotope migrates through the meridians. So it's measurable, but where does it show up? Yes, I practice, I'm certified in acupuncture too. Anyway, yes, a power's intention, that can affect that. It affects the biofield, what we eat, what we think, all that affects the biofield. That's one example, you can read it. Bad dog, drop Bobby's voodoo. Yeah, so that's intent. Intent is so powerful. There's an executive woman who just came from work. I wish for no housework, no cooking, no cleaning. Poof, it changes. So what's really happening? How do we change that, right? There's the universe. We are human antennas. Okay, we have antennas, but we have filters. That's it gets in the way. Vision, biases, politics, economic, all that. Those are filters. Our thinking, preconceived notions. In that human antennas, how we read the subconscious reality, the conscious reality, what we think is reality. What you see, I'm putting quotation marks because it changes as you change. As we change, that reality will change. But the more important to me, the superconscious reality, consciousness, also is affected dotted lines because that's more difficult. Okay. Now, wouldn't it be nice? That's another one that's filters. That's technology helping now. So for men, this is especially made for men, by the way. The white filter, you turn it off, you don't hear anything at all. It's kind of quiet. You think this is reality, huh? That's a photo. It's not a video. So we can peel the onion and say, why is this looks like it's moving, even though it is not? So your eye, the way it's built, the rods and cones and all that plays a game on the brain. So wouldn't it be nice to block those human filters, okay? So we can go directly from the universe to the antennas, which is what's happening to you with the nodular pulse. We bypass the filters. Oh, what is this? Cardiovascular pulse. Well, I have to pulse the rate and all these things. You felt it directly. So hopefully that will help us to look at the superconsciousness reality, consciousness itself. But the filters are getting in the way. So today, that's the physical measurements of fields, and you have the metaphysical on the other side. The intersection is small now, okay? Because we're using the instruments and our biases. Or there's no connection, so why even looking at it, right? So hopefully with science and engineering moving more, we'll be able to expand that intersection between the physical world and the metaphysical side. And that has been done a long time ago. William Tiller from Stanford. This is his model. And we're right here, positive space-time structure. That's physical chemistry, energy fields. But we need to go to subtle energy fields, which is moving in that direction, slowly. Noyer is what's called subtle energy, right? Then we can move into the physics of the magneto-electric field. Now we're talking there. So we have to develop the physics of that domain. But once we develop the physics, like physics drives chemistry, we have to develop the physics that will develop what's called etheric chemistry. Then we can practice etheric chemistry directly, like the Qigong masters do in China. When the first time I went to China, actually, I was surprised because they had this Chinese medicine section of the hospital and the Western medicine. And you walk in and you ask, you want Chinese medicine, you go to the right, Western medicine to the left. But they're in the same building, and the different. And in China, the people get a medical doctor in Qigong. They're Qigong MDs, and they do. The first time I saw them, it was just blown my mind. And this is a long time ago. Also, they're working, doing these things on the patient lying down. He said, I asked my host, I said, what are they doing? They're working with the energy fields. He said, but it's like grabbing something in the air, doing like that. So what are they? Yeah, because they're like fibers, luminous fibers, but we don't see them. They can feel them. And in pathology, they're tangled up or non-existent. They're too low. They need to be recharged in a sense. He doesn't use the word recharge, right? But that's what they were doing. And they were affecting pathology. It just blew my mind back then, So that's William Tiller. He wrote several books. One I recommend, this one is Conscious Acts of Creation. He's a physicist, by the way, okay? He passed on recently, last year. He just passed on. By William Tiller. He has several books, but this is the one I believe will be the nicest. Connects physics to the rest of the cosmic experience, okay? Mainstream, we're going to consciousness now. The current models right now, okay? The two main ones are the brain level and the information technology level. Those are the two biggest ones. This is all brain construct. Brain creates it. The others, no. We have a lot of information now. It's a way of gathering all the information to develop new ideas and new experiences. Very quickly, neural explanation. Consciousness is a brain product. Okay, that's what they say. Neuroscience, but the problem, neuroscience hasn't explained all the phenomena we see. Okay, from near-death experience and stuff like that. I'm sure you're familiar with all those things. It doesn't do that. Even that, with the what is the redness of red? Where does it reside in the brain? Okay, or the pain of pain. Well, you can measure with electrical activity and all that, EEGs. But the redness of red, that nobody has found that. It's the experience of it is not available. The information theories, we integrate lots of data, and they will somehow we come up with something, a super level of information or decision. So they talk about integrated information theory of consciousness, still done by the brain. So tries to quantify consciousness. Okay, it's just a numbers game. Panpsychism is along that line, like it's not just brain level. It expands the data gathering beyond the brain. And you kind of experience the Noyer pulse because your body received energy coming from your partner, okay, coming from the outside, and was integrated into your body. Okay, so that's called panpsychism. Pan means all. Psyche, panpsychism, everything's psychic, right? The whole world, the whole universe. Matter may not be inert at all, we already know that. It's conscious field waiting to be awakened by integration. That's the key. And I strongly believe in that. I have experienced and seen so many cases where that's what happened. How about quantum? Quantum consciousness. We're not there yet. Quantum is only for subatomic particles. Beyond that, doesn't. In fact, some people say, two people can be entangled from New York to California. Human beings cannot be entangled. Not yet. It doesn't work. It's too big. It's only down to the quantum level. Quantum mechanics. Is a, the observer and the act of observation collapses the wave function, right? We know it in quantum physics. So maybe that's what's happening for quantum consciousness. Well, that collapse is only at the subatomic particles on it, not the brain. But it could be, conceptually, this consciousness is missing variable. Yeah, it could be, but the physics is not there yet. But panpsychism already have the model available. Physics, the conventional physics, quantum mechanics, is not advanced enough. So do you see maybe the chart? In the future, there will be more science and technology to develop. Hopefully, will expand the overlap between physics and metaphysics. But that's future. We're not there. We're not there even at all. Check on this guy, Stuart Hameroff from Arizona. He runs, I met him probably 40 years ago, something, long time ago, in one of the early conferences. The Science of Consciousness has been going on many years. This is next April. But the one I suggest is to check for the 2024. It's available on the internet. The Science of Consciousness, but check the 2024 conference that happened in Barcelona, Spain. That all the speakers, all the articles, all the videos are available on the internet. That's beautiful. You just will blow your mind as to what researchers have been doing. But how come people don't know that? It's not being used in practical, not yet. Politics gets in the way quite a bit. But he's one of the people who have survived the political area because he founded what's called the Arizona Astrobiology Center. Just the name that tells you what he was doing. That's Radin talking. That's the 2024. He spoke about. I'm sure you have seen that about the Faraday cage and water affecting pH, right? But intent had been done so many times that he was talking about that in the Barcelona convention. So panpsychism conscious model is where the universe itself is alive. We are experiencing that relationship, that integration, if you will. So it's not outside. We are the receivers of that. And that he's the best person to explain the details. He's a physicist also, Philip Goff. And he has videos also, webinars and all that stuff. You can check on that, gets into more details on the scientific foundation. Again, the best science we have today, right? It's evolving. The best we can explaining what panpsychism is about. So, but in this model, consciousness is not just part of the brain. It's woven really into the fabric of the universe itself. It's the same. And you can, in there, from jump beyond that, you say, well, so what is God, right? I think we're asking the wrong question. People ask the question, what is God? You're looking at it. Reminds me of the two drunks. One drunk is on his four legs on the floor at night under a lamppost, looking on the ground. Another drunk passes by. Hey, what are you doing? I lost my car keys. Oh, let me help you. You see where you lost your keys under the lamppost? No, but there's light here. I don't know. See what I'm saying? That's what we're doing. Yeah, there's light, so we follow the light rather than what's really the question that we need to follow. So matter has a basic sense of experience. Photons do. But there's all sorts of experiments how mind can alter the photonic direction, right? That's magnets do that. So in astronomy, stars, for example, can bend the light. So it's called the astronomic lens. So, but that's a huge magnet. Intention also can do the same thing. And photons are electromagnetic waves. So when the experiment is doing a beaker of water, put a pH meter and put the beaker in a Faraday cage. Faraday cage means there's no way you can have EMF coming in and out, electromagnetic fields, right? Intent can also change the pH of that water. So that means the intent is not an electromagnetic wave, right? Because the Faraday cage is blocking it, has to block it. So what is that? See, there are other forms of energy beyond electromagnetic fields. And we talk about, the vacuum and the particle coming in the vacuum and all that stuff. So maybe consciousness is tapping into that energy coming from the vacuum, what we call vacuum, which is not vacuum, by the way. It's teeming with stuff, antimatter. The antimatter is on the other side. That's what some physicists are talking about. The universe was born from a black hole, the black hole that connects to the antimatter, the other side of the negative space-time that Tiller talks about. So that's, yeah, they're all teeming with moving energy, okay? It's just that we don't have this sensor to feel it. So when that touches table, it feels inert, that it's not alive. But that's our limitation, not really the reality of what's in there. So panpsychism, it's not animism, by the way, okay? It's a metaphysical model that addresses the limitations of the reductive mechanism. Right now, all the other models of consciousness trying to peel the onion to the smallest molecule, like the brain. Where in the brain is consciousness? That's the wrong question. See, that assumes that consciousness has to be in the brain to begin with. So we put the blinders right from the beginning. In the beginning was the world, yeah. Another physicist, Goswami. This book was published many years ago. One of the early paperbacks I bought. The self-aware universe. It's a nice little paperback. Even though he's a physicist, plain language. He's now getting into this heavy formulas and all that stuff. Yeah, we're affected by the way I'm having the next few slides. We're almost finished. Is I'm between you and lunch, right? So I feel the pressure. If all these models finish and all that, the backup, the fallback position is to admire the universe. Be in awe. This is what it is, and we are part of it. It's unbelievable, okay? That then tries to bypass the filters. But just look, when you look at the sunset, you may not know why the sky is red. Okay, the physics of the rays coming down, the deflects down, all make it red. But you can enjoy it, right? You can just look at light. I enjoy it both ways because I know what's happening, and it just amazes me that how light can changing, and the rainbow with reflecting through the water particles in the cloud and split the light into the primary colors. And it just gives you a different taste, I guess, for noticing things. So when I touch a table, yeah, I can feel the table, I can feel but I can think of it that there's more than just what my senses feel, okay? Gives a different, more taste for life, really. So look at this. This is the sun, that's the earth. We have magnetic fields coming in. It's deflected, okay?